Over 4,000 missiles were fired at it, not one hit. Enemy pilots tried to chase it. They never even got close. By the time radar locked on, it was already gone. This was the Lockheed SR-71 Blackbird, the fastest air-breathing manned aircraft ever built, and the deeper you go into its story, the more unbelievable it becomes. Welcome to Jet Insight. Today, we're diving into one of the most extraordinary achievements in aviation history, a machine so far ahead of its time that even today, no operational aircraft has truly matched its speed and altitude combination. The birth of an impossible aircraft. It was the late 1950s. The Cold War was escalating. The United States needed eyes deep inside denied airspace without getting pilots shot down. The answer came from Lockheed's legendary Skunk works, led by the brilliant engineer Clarence Kelly Johnson. His mission sounded simple: build an aircraft that could fly higher and faster than anything the enemy could intercept. The result? A reconnaissance platform capable of cruising above 80,000 feet at speeds exceeding Mach 3. It wasn't just fast, it rewrote the rulebook. The titanium secret. To survive sustained Mach 3 plus flight, normal aluminum wouldn't work, it would melt. Steel was too heavy. The solution was titanium. Here's the twist. During the 1960s, the largest supply of titanium was controlled by the Soviet Union, the very nation this aircraft was designed to observe. Through complex international procurement channels, the US quietly acquired large amounts of Soviet titanium. That same metal would become the skin of the aircraft flying over sensitive installations. Engineering challenge didn't stop there. Titanium was difficult to machine. Tools had to be redesigned, manufacturing processes reinvented. Every component demanded innovation. Nothing about the Blackbird was conventional.
The aircraft that expanded in flight at Mach 3, friction with the air generated immense heat. Surface temperatures could exceed 300 degrees Celsius, and leading edges became even hotter. The aircraft literally expanded several inches in length during flight. On the ground, fuel would leak from panel gaps. That wasn't a flaw, it was intentional. The gaps sealed when the aircraft heated up at speed. Even the dark coating wasn't just for appearance. The paint helped radiate heat away from the airframe. Everything about this aircraft was engineered around one principle: survive extreme speed. Fuel, unlike any other, the Blackbird didn't use standard jet fuel. It used JP7, a specially formulated fuel with an extremely high flash point. You couldn't ignite it with a simple match. To start the engines, engineers used triethylbrine, TEB. When injected, it ignited instantly, producing a bright green flash, a signature sight during engine start. The fuel also doubled as a coolant, absorbing heat from various systems before being burned in the engines. Efficiency, innovation, precision. The men who flew it. Flying at 80,000 plus feet meant operating at the edge of space. Pilots wore full pressure suits, similar to those used by NASA astronauts. The sky above them turned dark. The curvature of Earth became visible. Outside temperatures were lethal. These weren't ordinary aviators. They were among the most highly trained pilots in the US Air Force. Missions demanded absolute focus. There was no room for error at 3 times the speed of sound. Why no missile ever hit one? Over its operational lifetime, thousands of surface-to-air missiles were launched in its direction. None succeeded in shooting one down. The primary defense wasn't weapons. It was speed. Cruising above Mach 3, the aircraft could accelerate even further if threatened. By the time a missile system calculated a firing solution and launched, the aircraft was already miles away from the predicted intercept point. Speed was survival. Electronic countermeasures added another layer of protection, disrupting tracking systems if necessary. But most of the time, outrunning the threat was enough. Eyes. From 15 miles high, flying above 80,000 feet, the Blackbird could survey vast territory in a single mission. Equipped with advanced cameras and radar systems, it gathered critical intelligence during some of the most tense decades of the Cold War. Its true power wasn't firepower, it was information. And in modern warfare, accurate information delivered quickly can be more decisive than any weapon. The SR-71 was officially retired in 1998, but its influence never disappeared. Today, Lockheed Martin's Skunk Works is developing the proposed Lockheed Martin SR-72, often referred to as the son of Blackbird. The concept aims to reach speeds around Mach 6 using advanced propulsion technologies. Whether or not it fully materializes as envisioned, one thing is certain. The technological foundation traces back to the breakthroughs proven by the SR-71, the Lockheed SR-71. Blackbird wasn't just an aircraft. It was a demonstration of what happens when bold engineering meets strategic necessity. It pushed materials science to its limits. It demanded elite human performance. It redefined speed as a defensive weapon. Decades later, it remains one of the most extraordinary machines ever to take to the sky. And perhaps the most remarkable part, even today, it still feels like something from the future.